This is our fourth and final video in a series on solving trigonometric equations. So if you haven't watched me solve problems 1 through 12, you may want to go back and watch one or more of the previous videos. Now, there are two charts worth of information that you need to memorize. This is one of them. So if you don't know all of the facts on this sheet, like the cosine of pi over 3 is 1/2, then you need to pause the video, copy this chart down, and memorize it. Same goes for this chart of Pythagorean trig identities and their various versions. If you don't know these by heart, at least you need to get yourself to where you could create this chart on a sheet of scratch paper within a minute. So here we go. This one looks relatively easy, actually, because we only have one kind of trig function, sine. In fact, only sine squared. That means I should be able to put these together. So let's subtract sine squared from both sides, minus sine squared. Now be careful, that gives me 0 on the right-hand side. Don't let that throw you. So at the moment, then that's going to give me 4 sine squared, which I will put in front. Okay, because this is 5 sine squared minus 1 sine squared, if you will. And then I'll put the minus 1 second, because that just makes me feel more comfortable. Now, this looks familiar to me. I could actually factor this as the difference of two squares. Remember how if I have a squared minus b squared, then that's going to factor as a plus b times a minus b. So I really could factor this as 2 sine theta plus 1 times 2 sine theta minus 1. And I could go from there. However, I find that it's a little bit quicker if I simply get sine by itself. By if I add 1 to both sides, that will give me 4 sine squared theta is equal to 1. If I divide both sides by 4, that'll give me sine squared theta is equal to 1/4. And then I would take the square root of both sides. Now the only thing about this method is I have to be very careful to remember when you take the square root of both sides, the solution can be positive or negative. If you forget the plus or minus, you're going to leave out half of your solutions and you're going to get the problem half wrong. So this is going to give me sine theta is equal to plus or minus 1/2. So remember, the way we take the square root of a fraction is you take the square root of the numerator and the square root of the denominator. Square root of 1 is 1, and the square root of 4 is 2. Now it's time to talk about reference angles and such. So the reference angle comes from asking ourselves, sine of what is 1/2? Forget the plus or minus for now. Well, remember this chart I mentioned earlier? That's pi over 6. Sine of pi over 6 is 1/2. So that tells us that the reference angle is pi over 6. Now, in your mind, you should be picturing the following diagram, but you should not actually have to draw it. I'm only drawing it because I have to show you what I'm thinking. So this is a diagram of all of the multiples of pi over 6. Okay, just above and just below the x-axis, these are the angles that have a reference angle of pi over 6. Now, we're talking about the sine function. Sine is a y value on the unit circle, so as such it will be positive in the first and second quadrants and negative in the third and fourth quadrants. However, in this case, we want sine to be positive 1/2 or negative 1/2. We want both. So that's why it was so important that you did the plus or minus when you took the square root. So because we want both, we're going to keep all four of these. All four will be the solutions. So that's why the solutions will be pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. Now, one thing that I don't like about number 14 is that it has two different types of trig function in it, cotangent and cosecant. I'm looking at you, cotangent squared. That is going to be on my identity chart somewhere. And here it is in blue. Cotangent squared is equal to cosecant squared minus 1. So let's do that substitution. Alright, so right here I'm going to put cosecant squared minus 1. So that'll give me 3 plus cosecant squared minus 1. Alright, we have like terms here. So 3 minus 1 is 2. So this will be cosecant, cosecant squared plus 2. Now, when you have two different types of cosecant, one squared and one not squared, that's when you know that you need to get 0 on one side and factor. So I'm going to subtract 3 cosecant from both sides. And I'm going to wind up putting that in the middle. So I will have cosecant squared minus 3 cosecant plus 2 is equal to 0. Now this is most likely factorable, so let's try to factor it. Cosecant squared will only factor as cosecant times cosecant. 2 will only factor as 1 times 2. Now, the key to my method of factoring is inner plus outer must equal the middle. Inner, I have 1 cosecant theta. I multiplied those. Outer, I have 2 cosecant theta as I multiply these. The middle is negative 3 cosecant theta. I can make negative 3 cosecant theta out of this if I make both of these negative, which means both of these would be negative. I have to check this sign. Negative 1 times negative 2 is positive 2, so we are good. So I'm just going to erase this to get it out of my way. So now that we have factored it, we can set each of these factors equal to 0. So we will have cosecant theta minus 1 equals 0, and cosecant theta minus 2 is equal to 0. Adding 1 to both sides and adding 2 to both sides will give us cosecant theta is equal to 1, and cosecant theta is equal to 2. Cosecant is the reciprocal of sine. So doing the reciprocal of both sides will give me sine theta is equal to 1. The reciprocal of 1 is still 1. And sine theta is equal to 1/2. Alright, so let's analyze each of these for solutions. This is going to be a quadrantal angle, alright, where sine is equal to 1 is at either the x-axis or the y-axis, so let's ponder that. Let's look at the quadrants. So here we have 1 comma 0, 0 comma 1, negative 1 comma 0, and 0 comma negative 1. On the unit circle, sine is a y value, so we are only going to look at these numbers right here. In this particular case, we want sine to equal 1. So that's only going to be up here. Boom. Alright, so that gives me theta is equal to pi over 2. Alright, because that's what this is. Alright, now let's look at this. This is on the chart. Sine of what angle is 1/2? Okay, whoops, right here. Sine of pi over 6 is 1/2. So that tells me the reference angle. Alright, that doesn't mean the answer is just simply pi over 6. That tells me that the reference angle is pi over 6. Alright, but there's a little bit more to it than that. Consider a diagram of multiples of pi over 6. Alright, which you should not have to draw. You should be able to do this in your head. I'm just showing you what I'm thinking. So these 4 angles are the 4 angles that have a reference angle of pi over 6. Sine, we're talking about the sine function. The sine function is a y value on the unit circle. So y values are positive in the first and second quadrant and negative in the third and fourth quadrant. So which do we want in this case? Well, the sine of theta is equal to positive 1/2. So we want these 2 angles will be the solutions. Alright, so notice the answer is not just pi over 6. That's one of the solutions, is pi over 6. Alright, but the sine of 5 pi over 6 is also 1/2, so that has to be included. Alright, so these are the 3 solutions to the equation. Okay, so that was number 14. This problem is a little bit easy in the sense that it only has cosine in it. I'm going to rearrange it to put the highest exponent first. So I'm going to put my 2 cosine squared theta in the front, followed by 3 cosine theta, followed by the plus 1 is equal to 0. Now chances are this can be factored. So let's try to factor this. 2 cosine squared can only factor as 2 cosine theta times cosine theta. Skip over to the 1. 1 can only factor as 1 times 1. Now here's the key. Inner plus outer must equal the middle. Inner, I'm talking about these 2, will be 1 cosine theta. Outer, I'm referring to these 2. If I multiply those, I get 2 cosine theta. Now the middle is 3 cosine theta. These 2 put together can equal 3 cosine theta as long as I let them both be positive, which means that both of these will be positive, and it works out because positive 1 times positive 1 is positive 1. Always need to check that. So I'm just going to move this out of the way, erase that, so that I can set each of these factors equal to 0. So I have 2 cosine theta plus 1 equals 0, and I have cosine theta plus 1 equals 0. Let's do the left hand side first. Subtracting 1 from both sides, I get 2 cosine theta is equal to negative 1. Dividing both sides by 2, I get cosine theta is equal to negative 1/2. let's talk reference angles. Okay, cosine of what is 1/2? I'm ignoring the negative for now. Well, that is pi over 3. Cosine of pi over 3 is 1/2. So that tells me that the reference angle is pi over 3. Okay, so here is a diagram of all of the multiples of pi over 3. And again, you should not have to draw this. You should just be picturing it in your mind. These are the 4 angles that have a reference angle of pi over 3. We are talking about cosine. Cosine is an x value on the unit circle. X values are positive on the right-hand side and negative to the left of the y-axis. So in this case, we want cosine to equal negative 1/2. So that means these 2 angles will be solutions. So what have we got so far? So theta equals 2 pi over 3 and 4 pi over 3. All right, but there's more, because we also have the cosine plus 1 equals 0. So let's solve this guy. Subtracting 1 from both sides will give me cosine theta is equal to -1. So this is a quadrantal angle type situation. So let's go ahead and diagram that. Over here on the right, we have 1, 0, and up here is 0, 1, and then -1, 0, and 0, -1. Cosine is the x value on the unit circle, so we're only looking at these x values. Now we want cosine to equal -1. So that's only happening right here. And that is pi. So I'm going to add pi to my list of solutions, and that is it. Alright, and that was it for problem number 15. Okay, and this is the last problem, and it looks easy. A lot of the other problems were more complicated. Let's just add 1 to both sides. So that's going to give us cosine squared is equal to 1. Now we can take the square root of both sides. Please remember, when you take the square root of both sides, the solution will be positive or negative. So don't forget that plus or minus, or you will be only half right and you will get only half credit. So this will give us cosine, alright, it's not squared anymore, so cosine is equal to plus or minus 1. This is a quadrantal angle situation. And over here we have 1, 0. Up here is 0, 1. On the left is -1, 0. And down here is 0, -1. Cosine is the x value on the unit circle. So we're only going to look at these numbers, these x values. We want cosine to equal +1 or -1. Okay, so looking at the numbers I've highlighted, we have +1 here and -1 here. So that gives us the 2 solutions, 0 and pi. And that's it for number 16. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.